All right, so we're going to get into pressure and temperature conversions. This is going to be a big thing when we get into our gas laws. And we do this because there's several different pressures or units for pressure and several different units for temperature. So we're going to start with pressure. So the units for pressure are ATM, which is atmospheres, kPa, which is kilopascals, mmHg, which is millimeters of mercury, and then torr. And all of these numbers are equivalent. So 1 atmosphere equals 101.3 kPa equals 760 millimeters of mercury equals 760 torr. So we can use, because these are all equivalent, we can use them as conversion factors if we have pressure in one unit and we need it in a different unit. So how do you do that then? So let's say we have 5.5 atmospheres of pressure, and I want to turn that into kPa. Okay. Well, the way that I want you to do this is set up a proportion. So I know that 1 ATM is equal to 101.3 kPa, right? So what is 5.5 going to be related to that? So from here, you should be able to recognize that this is a proportion, and we're going to cross multiply and divide, right? So 1 times x is x. In this case, we're not going to have to divide because we have, so 101.3 times 5.5. So that's 557.15 kPa. So that would be my answer there. Okay. So let's try a different one. Let's say I want to know, I have 1200 millimeters of mercury. What is that in ATM? Okay. So I know that 1 ATM, and it really doesn't matter what you put on top and bottom so long as the equivalent. So if this is millimeters of mercury on the bottom, over here on the bottom I need to put millimeters of mercury. So I'll put 1200 down here and then X. So I need to make sure that the bottoms kind of match up and the tops match up as far as the same unit. Okay. So cross multiply, so 1 times 1200 is 1200, and then equals 760 times x. So then from here I'm going to divide both sides by 760. So x equals 1200 divided by 760, 1.58 atmospheres. Okay. So now what if I do, if I want to know, I have 500 kPa, and I want to know how much torr, how much that is in torr. So now I know my conversion is from 101.3 to 760. So I'm going to put 101.3 over 760, and then the 500, because that's kPa, it's going to match with the 101.3 kPa over x. So now I need to cross multiply. So 760 times 500 gives me 380,000 equals 101.3 times x. Divide both sides by 101.3. X equals, I'm going to divide this by 101.3, 3751, 3,751, and that'd be torr. Okay, so you're going to, again, you use these conversion factors, set them up in a proportion, and then the number given is going to be over or under the x, depending on how you're going to do it. Okay. okay, how you set up your problem. Now, temperature conversion is a little bit easier. We're going to use something new, which you probably haven't come across in your science classes before. You've probably used Fahrenheit and Celsius, but you have not used Kelvin. This is probably new. So we use the Kelvin scale when we're dealing with gases because it does not have negative values, and we don't want negative values when we're dealing with pressure and volume and temperature and things like that, because you can't have a negative pressure, you can't have a negative volume. It doesn't really make sense. So we use Kelvin because it's not going to give us a negative value. The way that I get to Kelvin, if I do the Celsius plus 273. So whatever the Celsius, the degrees Celsius are, I add 273. If I'm at Kelvin and I want to get back to Celsius, I just subtract 273. So it's pretty simple. Either add or subtract 273 depending on which way we're going. So if I have 50 degrees Celsius and I want to turn that into Kelvin, I do 50 plus 273. And that gives me 323 Kelvin. Okay. And if I'm at, let's say I'm at 300 Kelvin, and I want to go to Celsius, I do 300 minus 273, so that would be 27 degrees Celsius. Okay, pretty straightforward. Either I'm going to, again, subtract or add the 273 to get from Kelvin to Celsius, or vice versa. All right, I hope this helps. Let me know if you have any questions.